Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to really talk about how to use our calculator a little more to get some more info out of a polynomial where rational root theorem doesn't even work. Ideally, you always want to start with trying to use substitution or factor by grouping to solve a polynomial, but sometimes those don't work, and then you try rational root theorem. And technically, you can also just not have rational root theorem work because you could have no rational roots, like they could all be imaginary or something. So you need some other way to do it, and that's what I'm going to kind of talk about today. Start off, though, I actually want to do another rational root theorem problem. So this thing, 5 terms here, and you're not going to do substitution because you don't have 3 terms, and you can't do 2 groups of the same size. You have a group of 2, maybe a group of 3 or something, but you don't have the setup to do factor by grouping or substitution, so you're basically left with rational root theorem. My possible rational roots are going to be, p is factors of the last thing, so in this case 1, 2, 3, 5, 6, 10, 15, and 30. Whew. And then factors of 6 for the q. So that one's just 1, 2, 3, and 6. And again, any of these can be positive, any can be negative. I don't think I missed any there. No. And so this is a good example. This one has a lot of possible rational roots, right? And we need to find, at least one to get us started, and then it'll maybe turn into something we could do with some other technique. So this is an example of a problem where I'm going to kind of let you guys use your calculator to help you a little bit. And this is basically related to what we're talking about today too anyways. So a few classes ago, there was a video where I showed you how to use the max, min, and 0 buttons, which are under that second trace menu. So what I would do on this one to get started, because you could go and do some of these kind of quick. I mean, you can always do one fast, 6 minus 11 plus 8 minus 33 plus, minus 30. Let's see, that's going to be minus 30. Yeah, so that doesn't work, so that's not 0. But the idea is, like, you can always check a few, like 1 really quick or something like that, or -1. But a lot of them are not quick. And so what I would do is I would go and plug all that in to the y equals on your graphing calculator. Then go and find a 0. Okay, you'll see in this example, you'll actually see 2 rational roots. You'll see 2 crossing points on the graph. One is going to be over kind of like, if this is 1, 2, 3, 4. So 1 is like about here. You'll see it crossing there. And then another one is going to be kind of over around here. All right. You'll see another crossing point. And it's doing some other stuff in between. It doesn't really matter. But if you found either of those using the 0 command, they're actually going to be rational roots, which is nice. So let's just use, we're just going to use this one. So if you do it on your calculator, you're going to get 5 halves as a rational root. And then you got to do synthetic division. So we got 6, -11, 8, -33, -30. And then bring that down. And then multiply and add all the way through. So I'm just going to put down, hopefully we're good with this by now, so I'm just going to put down the numbers you should get. And you'll notice you get a 0 again, which makes sense because we know this is a root, so it should, if we're dividing in the factor x minus 5 halves, then we should get a nice perfect, no remainder situation. So that means we have a cubic 6x cubed plus 4x squared plus 18x plus 12. And all of those numbers are even, so you can divide by 2. So then 3x squared cubed, plus 2x squared plus 9x plus 6. And then if you look at this, these two, 3 to 2 ratio is the same as the 9 to 6 ratio. So that's given us a clue that we could probably do factor by grouping. So if you take x squared out here, you're going to have 3x plus 2 left over that first group. And then if you take 3 out of the next group of 2, you're going to have 3x plus 2 left over. So this is perfect. You got these common factors, which then you can take out, 3x plus 2, and you're going to have x squared plus 3, x squared left over from that group, and then 3 left over from that group. And then we're basically done because we've got linear or quadratic factors. So we could just solve those using like normal, techniques. So the root here, you minus 2, you divide by 3. That's going to be one of my answers. And then here, it's another nice quadratic. If you just think like x squared plus 3 shifted up 3, it's not crossing the x-axis. It's going to have roots of plus or minus root 3 with an I. So these two mixed with the negative 2/3 and then the 5/2, which I should also circle, are truly 4 roots. And that is a good example of one that you really would need to do rational root theorem. And I am okay with this. You can, when you have rational root theorem problems, in order to save you guys guess and check time, you can use the 0 button to get one of those kind of quickly. All right, so basically the assignment that you're going to actually be working on for next time is really just one where you're going to have all these applications of higher order polynomials, and all of them basically you need to use your calculator in some way. So all these questions, they basically use the max, min, and 0 buttons that are all found under that graphing calc window. And just this kind of like a quick review, this is what it kind of looks like. You have some sort of x cubed thing like this. This sort of thing, because it's 0.7, it's going to be a weird kind of problem. So you might just want to get started with one root. So you'll put it into y equals, and then, really, this one is not super useful. Basically what that does is given an x value, you can get a y value. But this is super useful, right? I would have used it in the last problem. And then max and mins, they are really important too. Max and mins, let's do it like this. So 0 is going to help you find like that number there. And then maximum minimums, find maximums and minimums, stuff like that. And all of them, to basically do them, you just do that left bound, right bound guess kind of thing. And, if you want to see examples of me doing that on a calculator, just go back a few videos. There's one where it's titled literally like max, min, and 0. And this will basically let us analyze different things now with them. Like, just like with quadratics, we had questions where, what is the max height of the rocket and that sort of thing. You can answer questions like that if you use the max and min kind of buttons or something. So that 0 one is also useful for kind of doing like shortcuts sometimes. So I wanted to show you really quick how we can use that. And I also said down here the intersection tool can also be used, can be useful at times. And the intersection tool, it's found in the same area, and it basically acts the same as the max min stuff and the 0 one. You basically just do left of an intersection, right of an intersection, and then guess. And what this literally can do is, like, if you had two lines or something, that are crossing on your screen, you can be like, here's my intersection. I'm going to go click left bound of it, right bound of it, and then guess. And it'll basically ask you to, curve 1, curve 2, or something like that. It's fairly self-explanatory once you've seen maximum and minimum, but it can be useful too. But I want to show you a problem really quick where the 0, 1 can be super useful. So if this is actually an old published SAT problem, and they literally are just saying, what is one possible solution to this equation? And if you have a graphing calculator, and this was on a calculator section, you can do it really, really, really fast. So the way I would do this is, so basically go to y equals menu, and I would just type in 24 over x plus 1 minus 12 over x minus 1, and then minus 1, all right? And because what this is saying is basically, if you move the 1 over, right, it's saying when does that whole thing equal 0 now? And so what you can do is if you plug in y equals this, right, if you do it, and you should kind of check this out, basically you get something that kind of looks like, it's like one of these weird graphs where there's some undefined stuff, because you can't plug in -1, you can't plug in 1. It's got some undefined stuff at those points. But it actually doesn't look quite like that because it crosses. It does something like that. And what you can do on your calculator is you can see it's crossing, and then you can just use the 0 button. That's how, like, a really, really quick way, without really even needing to know how to do math, you can just get the answer. So, so this 0 button isn't just useful for polynomials. This is not a polynomial. This is something called a rational function. I think I defined it in a previous video too at one point. But you can use the 0 button there, and just for completion's sake, this is 5 and this is 7. And you could have found 5 or 7 just off of your calculator if you know how to use that 0 button. So I just wanted to show another quick example of like how this is useful for other problems too.